Hi guys, here are your notes for section 6.2. We're still working with functions, and today's section is all about an inverse function. So let's just remember what a function is. A function is an input-output machine where each input has exactly one output, right? That's that function's fancy definition. Well, an inverse function is really simple. What an inverse function does is it has to undo whatever the original function did. So an inverse function is a function that undoes another function. So an inverse function will undo all of the operations that are being done in the original function, all right? I have to put a little bit of a disclaimer. By definition, the inverse is a function, so it must follow function behavior, and therefore not all functions have an inverse, and the inverse will not exist. All of the functions that we deal with today are going to have an inverse. I just feel like I need to put that, but you don't need to worry about it yet, okay? But just note that not every function actually has an inverse, but that comes much later. But I just wanted to put a note there, okay? All right, so for example, if an inverse function has to undo what an original function does, well, then let's say I plug 9 into a function and I get 14 out. That creates the ordered pair 9, 14, right? 9 went into the function did something to 9, and it spit 14 out. Well, what happens then is if I plug 14 into the inverse function will undo all of the operations that happened to 14, and I should get the 9 that I originally plugged in back out. So that then creates the ordered pair. 14 went into the inverse, and now 9 came out. So it creates the ordered pair 14, 9. So the original function plugged in 9 and got a 14 out. The inverse function plugs in 14, undoes everything that happened to it, and you get the original input that you started with back out. That's what an inverse function will do. It'll undo whatever happened from the beginning, okay? All right, let's look here. So let's say you plug -8 into a function, and I get -3 out. That creates the ordered pair -8, -3, right? -8 went into the function, and -3 came out. Well, if I plug -3 into the inverse function, it's going to undo all of those operations, and I should get -8 back out. So then that creates the ordered pair -3 went into the inverse, and -8 came out. All right, so look at the ordered pairs. 9, 14 was created by the original function. 14, 9 was created by the inverse function. Even here, -8, -3 was created by the, oh, sorry, I have paint on my finger. I was painting today. -8 went into the original function, and -8 came out. Or -3 came out. So then -3 goes into the inverse, and -8 comes out. So if you notice, from the original function to the inverse, it reverses the ordered pairs. X and Y literally trade roles. The X's in the original function become the inverse's Y's. The Y's of the original function become the inverse's X's. They literally trade roles. The original XY's trade places with the inverse's XY's. All right, so I made a little chart for you down here. So this is how it works. So X goes into the original function, and Y comes out. Therefore, the point XY is on the original function's graph. So think of it like 9 went in, and 14 came out. That's a point on the original function's graph. And then the Y value, his output, goes into the inverse function, and X comes out. Therefore, YX is on the inverse function's graph, right? So now 14, the original Y, goes into the inverse, and then 9 comes out, the original X. So XY, YX. So XY are on the original function's graph, and YX is on the inverse function's graph. Their X and Y's literally trade roles. His x's are the inverses y's. The original y is the inverses x, okay? So therefore, x and y trade roles. And a little bit of a spoiler, we've just seen that x and y trade roles in the ordered pairs, but they also are going to trade roles in the equations too. That's what we're going to use today. All right, so the original functions y's or outputs become the inverses x's or inputs. And then the original functions x's or inputs become the inverse functions y's or outputs. So this is why their domain and range trade too, because their x's and y's are trading spots. But that comes later too. All right, so let's give today a whirl. Our job today is to be able to find a function's inverse. Okay. So look at this example. In example 1, it says, given this function f of x equals x plus 3, find its inverse function. And we want to write it in slope-intercept form. That's what the homework is going to ask you on Delta Math. All right? Well, think about it. You're going to plug a number into this function, and you're going to add 3 to it. The inverse has to undo that. Well, you should already know what we need to do to undo adding 3. What kind of operation will undo adding 3 to something? The inverse should require us to subtract 3 to undo that adding, right? But this is how you officially find it. All right, so step 1, take the original function, f of x equals x plus 3, replace f of x with y, right? Because we want to see an x and a y. And f of x literally represents the y anyway. So we're going to replace f of x with y. So we're going to rewrite this as y equals x plus 3, okay? All right, step 2. Since x and y literally trade roles from the original function to the inverse, we have to make them trade. So make them trade spots, switch them. We're going to rewrite this as x equals y plus 3. Okay, but now the way our functions work is we want x to be the one going in and y being the one who comes out. Right now, y is going in and x is coming out. We don't want that. So now you have to resolve this for y. And it's in the resolving that you're going to be creating the opposite or inverse operations that the inverse needs. All right, so resolve this for y. So what do you have to do to get y by itself? I have to subtract 3 to the other side. So minus 3, minus 3. Okay, so now I have x, subtract 3, which I can't do, so they have to stay separate, equals y. Well, I have a little bit of OCD, so I like to rewrite this as y equals x minus 3. Perfect. Guys, that's the inverse. That is the function that will undo what the original function did. The original function takes a number and adds 3 to it. The inverse is going to take a number and subtract 3 from it. It's going to undo everything the original function did. Okay, well, instead of circling this as your answer, we write the notation for the inverse as it looks like f to the negative 1 of x, but this is literally read as f inverse of x. So we're going to replace y with this notation. So it's going to be f inverse of x equals x minus 3. And that's what we officially say is the inverse function. Whatever you plug into this function and whatever you get out, if you plug that output into the inverse, it'll undo it and get you right back to your original input. Watch, let's say you plugged in 5. If you found f of 5, right? 5 goes in, we add 3 to it, and 8 comes out. So that's the ordered pair 5, 8, right? That's how the original function works. Well, now, if you plug 8 into the inverse, you're going to get 8 minus 3 equals 5. So 8 went into the inverse, and 5 came out. See how their ordered pairs are opposite? That's an inverse. It's going to undo whatever the original function did. 5 went in, 8 came out. You plug 8 into the inverse, and you get that original 5 back out. All right, perfect. All right, let's try it again. So let's say they gave you this function, and your job is to find its inverse, right? What function will undo everything that he's doing? Well, first things first is replace f of x with y. So it's going to be y equals 2/3 x minus 4. Okay, well, to create the inverse, you have to make x and y trade roles. So literally switch them in the equation. So we're going to rewrite this as x equals 2/3 times y and then minus 4. All right, but now we have to resolve it for y. So get y by itself again. So add 4. Okay, so now I have x plus 4 equals 2/3 times y. Well, there's a couple things you can do. What the Delta Math is going to show you to do in their examples is one way to get rid of a fraction. Yes, you could divide, but then you have to divide all this by 2/3, and that can get a little bit messy. The easiest thing to do with a fraction is to multiply it by its reciprocal. If I multiply this by his reciprocal, 3/2, it'll cancel to 1. And then we're good to go, and y will be by itself. But then I have to times this side by that reciprocal, 3/2. So we're going to end up with distributing our 3/2, right? So 3/2 times x is 3/2 x. 3/2 times 4, well, if you think of 4 as 4/1, that's going to be 3 times 4 is 12, over 2 times 1 is 2. So 12/2, that's 6. So plus 6 equals, and then y is by itself. So that is your inverse function, right? But I like to rewrite it as y equals 3/2 x plus 6. All right, and then we have to put it in that fancy notation now. So replace y with that inverse function notation. So f inverse of x equals 3/2 x plus 6. And it may not look like it, but that is the function that will undo everything this function is doing. And if you don't believe me, you can always try and plug a number in, get a number out, take that output, plug it into the inverse, and I'm telling you, it'll spit out the original input that you started with. All right, so that is your inverse function. Let's try it again. Let's say you were given this function, f of x equals 3x plus 5, right? Find its inverse, right? Find a function that will undo everything this function is doing. Well, the first things first is let's rewrite f of x as y equals 3x plus 5. Well, x and y have to trade roles, so switch them in the equation. X equals 3 times y plus 5. But now we have to resolve it for y. So let's minus 5. Minus 5. And now we get x subtract 5 equals 3 times y. Well, what we have to do now is divide by 3. But remember, they asked you to leave it in slope-intercept form. So let's divide everything by its own 3. Divide by 3, divide by 3, divide by 3. So now that's going to leave us with y equals, I'm going to switch it right now. Let's see, x divided by 3. Well, really, that's a 1x divided by 3, so it's 1/3 x, and then minus 5/3. Okay, and then again, just to finish it off, we replace y with f inverse of x equals 1/3 x minus 5/3. Okay, and there is the function that will undo everything that this function is doing. Okay, all right, last one. All right, so f of x equals the opposite of x, or a negative x minus 6. So first things first, replace f of x with y equals negative x minus 6. Switch x and y, so x equals negative y minus 6. Okay, and now we have to resolve this for y. So add 6, and you get x plus 6 equals negative y. We have to get y by itself, so think of that as a negative 1. So let's divide everything by a negative 1. And then you get negative x minus 6 equals y. Or I'm going to switch it up, y equals negative x minus 6. Put it in the fancy notation, replace y with f inverse of x equals negative x minus 6. And that is the function that will undo everything this function is doing. Now, I know this one looks weird because you end up with it looks like the same function, and it's true. So what happens is the original function is his own inverse, and that's just because it goes a little bit more into detail as we learn more about inverses later on. It's because of this negative x. If you have a negative x in your original function, plus or minus any number, it's this negative x that makes his inverse himself. So you didn't do anything wrong. It's normal. You just get the same function for something that has that negative just x right there. Okay? All right, so this is what your homework will be like on Delta Math. I think you have to get 8 right, and then for each one you get wrong, they'll add on another one. But you get 2 tries on each problem before they add another problem on. But you have to get 8 correct, okay? All right, text me if you have any questions. Good luck.